So for part C, we want to really pay attention to this caution or show that it diverges, and really look at whether this integral might be improper. So this time, when we go to, we're still going to look at factoring the denominator first thing. So this is going to be the integral from 0 to 2 of, so if I factor that denominator, I get x minus 1 squared dx. And it's important that I call it x minus 1 squared, not x minus 1, because this tells me that I can integrate this as u to the negative 2 power. All right, and then if I think about, where's the vertical asymptote? So this graph has a vertical asymptote at x equals 1. And that is in the interval 0 to 2. So that means I'm going to have to look at breaking up this interval. So if you think about like what's really going on here, what does the graph of 1 over x minus 1 squared look like? So here's our x-axis. Here's our vertical asymptote at x equals 1. This is an even asymptote, and the function is always positive. So since it's an even asymptote, the function's going to look like this. You can also see, if you analyze the analytic function, that it has a horizontal asymptote at x equals 0. So this is what 1 over x minus 1 squared looks like. So that means that when we do this integral from 0 to 2, we're going to have to look at what happens at x equals 1. And so the important way that we're going to break up the limit is that when I look at the integral that goes from 0 to 1, I'm going to be approaching 1 from the left. So I'm going to be using limit as x approaches 1 from the left when I do this side of the integral. And when I do this side of the integral, I'm going to be using limit as x approaches 1 from the right. So it might be important to really track those different one-sided limits that are happening in there. All right. So the first thing I'm going to do is split this up just into two integrals. So I'm going to call it the integral from 0 to 1, and I'm going to go ahead and write my rational expression with the negative exponent, the negative 2 power, dx plus, this is integral 0 to 2, sorry. Integral 0, it was integral 0 to 1, and then we're going to do 1 to 2 of x minus 1 to the negative 2 dx. Right, we're doing 0 to 1 and 1 to 2 because that's 0 to 1 and 1 to 2, how we're breaking up that interval. So now we're going to look at how I'm going to call this the limit as b approaches 1 from the left of the integral from 0 to b of x minus 1 to the negative 2 dx. All right, so the first thing I'm going to do is look at changing that number 1 where that endpoint of the interval, the function is undefined, but change that 1 into a limit. And I'm going to call it b just because it's on the top. You can call it whatever you want it. But I'm going to say my b is approaching 1 from the left because that part of the interval is to the left of x equals 1. And then, so likewise, my other integral is going to be the limit as a approaches 1 from the right of the integral from a to 2 of x minus 1 to the negative 2 dx, right? So 0 to b and a to 2, where b is approaching 1 from the left and a is approaching 1 from the right. So that just geometrically is how that's going to work. Okay, now I can just do my straight antiderivatives. So I have limit as b approaches 1 from the left of the antiderivative of x minus 1 to the negative 2 is negative x minus 1 to the negative 1. This is really an inside function, u equals x minus 1, but again, du equals dx, just like in the last part, so I don't have to track it. And then this is from 0 to b, and then plus I'm going to have limit as a approaches 1 from the right of negative x minus 1 to the negative 1 from a to 2. All right, and then I should go ahead and do my plugins and plugging in the top and the bottom. So when I plug in the top, I'm going to be actually using the variable b. So that's where the limit's going to show up. Limit as b approaches 1 from the left of, let's go ahead and write this as negative 1 over, and I'm substituting that b in there, b minus 1. So that x to the negative 1, x minus 1 to the negative 1, I'm writing as 1 over b minus 1 because I'm substituting in the b. And then what I'm going to do is put minus negative, plugging in the 0, so plus. Now when I plug in the 0, I don't need the limit because that expression isn't going to have b in it. So I'm just going to have 1 over 0 minus 1. right? So when I plug in the 0, there's no limit because there's no b. I'm using plus because the fundamental theorem gives me a minus. The function was already negative. Minus a negative is positive. All right, and then I do the same thing over here. This time I'm plugging in the 2 first, so I can go ahead and put in minus. I don't need the limit in the first step since I'm not using the a, so I'm going to have 1 over 2 minus 1. And then I'm going to have minus, I'm going to plug in the a, I'm going to have a minus from fundamental theorem, but then another negative from here. So let's call it plus limit as a approaches 1 from the right of 1 over a minus 1. All right, so plugging in the a, now I do have to have the limit, and it's positive because it's minus a negative. I'm approaching 1 from the right because of the geometry up here. I'm approaching the 1 from the left here because of the geometry on this side. All right, now I just look at this and say, all right, well, if I look at what's going on as b approaches 1 from the left, so this denominator is going to go to infinity. And in fact, it's pretty easy to figure out that limit as b approaches 1 from the left of negative 1 over b minus 1 equals infinity, and the limit as a approaches 1 from the right of negative 1 over a minus 1 is equal to negative infinity. Since that is the case, the integral diverges. Now, of course, they wouldn't have to both be infinity. Either one could be infinity. If either one of these is infinity, that integral diverges, and that's it. So this integral diverges. I think in the solution they say that this limit does not exist, which is a little bit, I don't think that's correct. The limit does exist, it just happens to equal infinity. What they mean is the limit is not a real number. And if that limit is not a real number in an improper integral, then we say the integral diverges. If it's not a finite number, we say it diverges. So there's part C.